My name's Phil Zito. Today we're going to be talking about how to build out a facility maintenance, preventative maintenance schedule. So right here, if you scan this QR code, and they said I could do this, so if you scan this QR code, you can download this little cheat sheet. If you do, you'll get entered into a drawing for a free course of your choosing from our course library. So feel free to do that, fill out the questions, and download that. So I like to make these interactive. At any point in time, if you have any questions, like we could totally go off script here. Just got to make sure I finish here at 5:30. So feel free to raise your hand, ask questions if I say something that's not clear. If I say something you disagree with, hey, it'll make it more fun and interactive. All right, so how many of you all are in the facility maintenance space on the owner side? There's a part where you raise your hands. All right, okay, so quarter of the room. How many of y'all are on the contractor side? Okay, quarter of the room. And then any OEMs, manufacturers? All right, cool. So a mix, awesome, good stuff. Okay, so by the end of this session, if I've done this right, you'll have created a list of systems that matter for your facilities, or you'll know how to teach your owners how to do this. So feel free to take pictures or whatever. I think they'll give out the slides afterwards. If not, just come grab my card. I have no problem doing that for you. You'll understand facility maintenance versus preventative maintenance. You'll have a risk-based PM structure you can implement. And you'll have at least one PM task that you can drive based on building automation system data. So just to ground things, FM, facility maintenance. So that's going to be reactive maintenance in this presentation. Preventative maintenance, that's going to be proactive maintenance in this presentation. And building automation system, for the sake of this, is going to be building automation of HVAC systems, just for simplicity's sake, so we can ground some terms. Anyone got any questions on that before we start diving in? All right, cool. Okay, so you're gonna want a pen and paper because we are gonna have a couple exercises as we move through this, so feel free to take notes, feel free to write things down. So why do most facility maintenance and preventative maintenance programs fail? You know, this is a question I've wrestled with for a while because you have facilities that have been doing this for a long time, yet it seems like we walk into facilities every day and they've got tons of deferred maintenance, they've got systems that aren't running. I went to a large manufacturer of grains and they had a chiller down for probably 4 hours and they didn't realize it because they had 40,000 unacknowledged alarms. So, you know, they had these issues that were going on and they weren't aware, and they had just got done telling me how if they lose cooling, they'll actually lose a test lab where they're testing out a new product, and they've been testing out that product for 6 months, and so they'll lose 6 months of that product. So not very good, right? So what we find is while the product and manufacturer checklists are great, let's go, wait, there we go, so we're not double dipping. It's not necessarily the best way to actually go about building out a preventative maintenance structure. Because let's say a VAV box goes down in a hospital lobby. Not really a big deal. VAV box goes down in the middle of heart surgery in an OR. That is a big deal, right? So not all failures and preventative maintenance processes are equal, but you have a lot of healthcare folks who they only have so much bandwidth. So do they go work on the VAV system in the OR, or do they go work on it in the lobby of the hospital? If there's no thought or process and we're just doing things, you know, because it's how we've always done them, that's how you have non-critical systems being maintained, which my hope by the end of this is you'll have a list of critical systems and you'll think through PM and FM from a different perspective. They're scheduled by calendar instead of risk. So for our sake, risk here is business risk. That may be anything. You know, if you're in healthcare, that's something that impacts patient safety. If you're in K through 12, it's something that keeps you from bringing students into the school. If you're a manufacturer, it shuts down your product line. So that's what we're going to define risk as. It's disconnected from the building automation system, so you have no way of actually seeing it. And then it's never reviewed or adjusted. Most folks I run into, and I have no judgment against anyone for doing this, because like you all are trying to do stuff with less labor than you've ever had and with more data than you've ever had. So not actually looking and adjusting your schedules. All right, so what I would do if I were you is I would just take a second, not too long, and just think about like what of this applies to your facility, because as we go through this presentation, I'm gonna give you some tools that hopefully you can take back, some like really easy, just mental models that you can apply to your facilities. So why does maintenance exist? Well, it exists in my mind. This is the world according to Phil, and I'm the one with the microphone, so all right. It exists to prevent high impact failures, so stuff that's gonna impact your business, to reduce your reactive work, right? I guess I can look at it here so I can see you all. All right, to reduce your reactive work, and to extend equipment life, and to maintain your operational performance. So if it's not hitting one of those four things, I honestly would ask you to question, why are you doing this maintenance? You know, because I've seen a lot of people, filters are notorious, right? Every quarter we're gonna do a filter change out. Doesn't matter if the filter's clean, we're still gonna change it out because that's what we do. Instead of putting a static pressure sensor that looks at the differential and then says, you know, hey, we've got perfect flow through this filter, we don't need to take it out and throw it out. It's kind of the Ron Burgundy. Who's seen Anchorman? Okay, a couple of you, right? Ron Burgundy reads anything that's put on the teleprompter. Well, a lot of maintenance programs, they do anything that's on the maintenance schedule. That's not necessarily the most efficient way to approach it. So if a task does not support one of these outcomes, this is the whole premise of this presentation, that I would question if it belongs within your maintenance program. So step one, let's identify the systems that matter. So this is where I want you all to list out systems where failure is going to cause a safety risk, operational downtime, mission failure, or regulatory exposure. So exposure, that's a new word, by the way, that's when things explode and you get exposed at the same time. So let's write down your top 5 systems. So for those of you who are on the FM side, think about that. For those of you who are supporting your customers, now, here's why you want to do this if you're a contractor or a manufacturer, because you're going to use this information to go sell service to your customers. So in healthcare, for example, that would be, you know, anything that impacts the OR, that impacts the imaging, that impacts the actual pharmacy storage, that impacts, you know, any of the lab storage, anything that impacts the patient rooms, especially if you're dependent on reimbursements. K through 12, you know, you're looking at cafeteria, gym, student rooms, et cetera. So you can kind of see how this cascades. So if you write down those top 5, because we'll use those a little bit later in the presentation. All right, so now we want to assign risk tiers. So this is kind of one of those judgment calls that you have to make. Tier 1, so this is more qualitative than quantitative. Qualitative means it's kind of up to your interpretation, it's how you feel about it. Whereas quantitative is like, you know, 50% of something. It's a definable number that you can define and defend. So right here, we're gonna say failure's unacceptable. That's tier 1. So like if the chiller goes down in a data center, we would argue that's, you could say it's unacceptable. You could potentially say it's tier 2 depending on the structure of the data center. But if power goes down, then that could absolutely be a tier 1. So it's all how you look at it. And it might be, you know, flipped in a healthcare scenario. Then tier 2, that's failure degrades performance, and tier 3, failure causes inconvenience. I'm going to argue that if you simply get your FM and PM responses, once again, remembering that facility maintenance, FM, is reactive, PM is preventative. If you simply go and list these out as tier 1, 2, and 3, then you're gonna find that you're able to deliver some efficiency and get some time back in your day. So I have the premise that you should stop treating all assets the same. in my experience, most PM, so most preventative maintenance, waste is coming from equal treatment. Now I'm curious, if you disagree with me, I want to hear it right now. Do you think that in your facilities right now, your PM is split up by the actual tier levels of your assets, or is it just kind of, hey, this is what we've always done? Yeah, I mean, and that's fair, right? Because like you're getting barraged by everything. CEO's calling because his office is hot, and then, you know, you're getting like the secretary's hot or cold, and you're getting barraged by that stuff. Meanwhile, core systems are just slowly degrading, and then something blows up, and then it's like, hey, how quick can we get a new one? So that's very normal. There's no judgment. You're in pretty good company. All right, so if we're able to go and actually list out our tier one, then we might be able to turn that around. So how do we do this? Well, we look at the, too many clicks. So we look at the actual OEM tasks, and we want to replace them with failure prevention. So let's do a thought experiment here. I'm very familiar with healthcare, so we're just going to play in that space. But let's talk about a hospital, and let's talk about an operating room. And this is where you all get to participate. What do you think is the most common failure for HVAC or building automation in an operating room? What's that? Humidity, okay. But what causes, like high humidity or low humidity? Sure, well, pick one. This is your answer. You are the captain now. Okay. Awesome. Okay, so high humidity. So let's go a step further. What causes high humidity? Okay, so anyone want to help her? What do you think causes high humidity in an OR? What's that? Not condensed. So we're not hitting saturation. So if you remember that beautiful psychrometric chart that all of us have seen once or twice, you know, that little curve right there. And as you do mechanical cooling and you move across that curve and you hit saturation where it's 100% relative humidity and you can't saturate anymore, and that moisture just starts to drain out and it overflows your condensate plants that haven't been cleaned in a while and trips that alarm. That is one of the ways that we go, right? And we could do that through subcooling. We can do that through decascent. You know, there's a variety of ways we can do it. But yeah, absolutely. So humidity systems failing. So then, what would that potentially look like if we were to say our humidity systems, they could potentially fail, and that could be from, you know, our condensate pan issue. You know, I came home one day and my AC wasn't running. It was because my condensate drain was plugged. So these are some, how we can start to think through what are our failure paths. And you know, you said, hey, I'm not a tech, but I'm sure you have access to some tech. So you could talk through them and say, hey, how could this fail? And then my premise is, as we'll say later on, let's build PM and FM around how things could fail rather than just some static schedule. All right, so let's define failure modes explicitly. So how I like to do it is what fails first, and you kind of saw me do that, right? You saw me say, hey, it's humidity, high humidity, but what causes us to get rid of high humidity? Well, it's either, you know, subcooling or decascent, and then how do we go and approach that? Okay, so if it fails, what condition causes the failure, and then what warning signs appear? So for example, that condensate pan that is plugged up, the condensate drain's plugged up, it's causing us to go and trip. Well, maybe we start to notice water pooling, we start to notice stains. There's things that we can start to notice because that sheet metal, typically the pan, and we can start to notice rust forming. Why are we having rust forming if the water's just draining out? Well, probably because it's pooling. So this is how you can start to think about, hey, what are the things I should tell my people? Like, this is a key thing. If I see rust on my condensate pans, then I should check my condensate lines to think through, hey, maybe there's a plug or something's not draining as fast. And that little fix will save a lot of headache. So how do we tie this to building automation data? So some of the common indicators, runtime hours. So these are like leading indicators. So everyone familiar with leading versus lagging? Okay, so for those of you who aren't, so a leading indicator is something that you can look at right now and it has a high likelihood that it'll predict a result. A lagging indicator is the result. So if I go and I decide tonight that I'm going to eat a ton of pizza, I'm gonna just freaking pizza out, there's a high likelihood that I'm going to be smacked by my wife because I'm snoring. So that's a leading indicator of how many slices of pizza I eat. Now the lagging indicator would be the lack of sleep I have because I get woken up for eating too much pizza. Kind of get it? Makes sense? So I guess I'm gonna be eating salad tonight. All right, so runtime hours, alarm frequency, trend deviation, sensor drift. These are all things that you can set up trends, you can set up alarms, you can set up histories that will help you indicate your key systems. So whenever you are buying a new system, for those of you on the FM side, you're buying a new system, the temptation's gonna get a spec from your engineer and just follow whatever alarms and settings they want. I'll encourage you to ask them like, hey, what systems are the most likely to fail? And then based on that, I would say, hey, can we set up alarms that'll give us kind of the canary in the coal mine that this might fail and give us a heads up before it does. Any questions so far? You all tracking with me? Pretty clear? Okay. All right. So right now, we've identified a top tier asset. I'd like you all to identify at least one data point for a failure mode for that asset. So just spend a couple seconds on that. If you can't come up with any, I'll tell you a few in a second. So we'll just give it a second. I'll drink some water. All right, so some of the most common ones I'll see, filters. Obviously, that's a big one. If you start to notice that your fan is having to really push harder to get the same static pressure and your boxes are at the same position, then that's usually an indicator of like maybe fan belt, maybe filters, maybe some sort of damper issue. If you notice your cooling at the same valve position is taking longer with the same ambient, ambient's just a fancy way of saying outside conditions. So if it's 80 degrees outside and you're normally able to cool the building at 50% valve position, but then 3 months later, same outside temp and it takes 75%, then that may be a clogged coil. There may be a variety of things going on. So these are kind of signs you can look at to indicate that there are failures creeping up before they become major failures. So here's an example. So one I see very often is with fans. So you start to have some belt degradation. I don't know if any of y'all have seen this before, but you'll have excessive runtime and you'll start to see rising fan speed. So that fan is speeding up because that belt tension's starting to drift. So then that fan has to speed up more and more and more, especially if it's got speed drive on it, right? And so right here, you could look at a trend, see, hey, for the same pressure set point and the same internal conditions to my building, my fan is ramping up more and more and more. And so as you start to see these things, and I know some of you all aren't BAS and HVAC experts, and I want to teach you kind of some mental models to think through this. I like to think of things outside of the HVAC concept. It tends to help. So if I notice that I'm going on a treadmill because I want to start running, because I want to get back to running again, and I notice that my heart rate is starting to increase more and more and more, and I'm going the same speed, and I've done the same amount of sleep, and I haven't eaten anything funky, then I have to ask myself, like, why is my heart rate increasing at the same speed with every other condition? Well, maybe, I've got a blocked artery or something. Maybe I'm got a plugged nose and I can't breathe right. So just start to think through it that way of like a building is a living system and what could be causing these things to be different. So you don't have to be an HVAC expert. You just have to say like, hey, this was like this, but now it's like this. Why? and then find the expert to actually help you out. Does that make sense? Okay, perfect. So let's separate our facility maintenance from our preventative maintenance. So the facility maintenance is going to correct existing failures, and preventative maintenance is going to prevent future failures. So, okay, right now you've got a top tier piece of equipment. You listed that out. You went and listed out some ways it can fail. Now what I'd want you to do is say, okay, of your tasks that you do for this scenario, what of those are facility maintenance tasks and what of those are preventative maintenance tasks? So if you want to write that down, an example, let's go back to our air handler. And if you're going around and replacing belts as part of a preventive maintenance task, that's one thing, but going in like having to replace it for a FM task, that's a different thing. Same task, but what are you doing? So if you start to see that the fan speed is increasing and the runtime's increasing, maybe you proactively go do that task. So you're taking it from being a potential failure down the road and you're replacing it with a preventative maintenance task, but you're doing it based on the actual data. Do y'all see kind of the loop there? It's a different way of thinking of maintenance. It's basically condition-based maintenance. Have y'all heard that term before? Okay, perfect. Please.
So, could you also factor in, like, you got the tier 1, tier 2, and tier 3?
Yeah.
So say something critical. Now, you having your belt blowing, you may not be seeing something now, but say you're sourcing outside for your service and stuff like that.
Yeah.
Would it be in that sense like okay to replace the belt because it's a critical system?
Yeah.
And you don't want to run the risk of making sure that with a tier 1.
Yeah, and that's a good point. Colin, right? Yeah, so Colin, you make a really good point. And that's where, by thinking through this, if I have to go and be preventative, I'd rather be preventative with a tier 1 asset than a tier 3 asset, because you have limited OpEx. You have limited material budgets. You can't just go buy fan belts and filters all day. So yeah, absolutely. That's the key concept of ranking these things. So if you have $1,000 that you can apply to a problem, you apply it to the systems that most likely aren't going to rely or create a contractor truck roll that's then going to cost you a whole bunch more money. Yeah, so you're spot on. You all see how like simple that is, right? Okay, so how do you decide? Well, if the task exists because something's already broke, it's facility maintenance. If it exists to do a filter or prevent a failure, my gosh, it's 5 o'clock. It's a preventative maintenance. So what I encourage you to do is to think through this and reclass a task. So what this would look like is you would have so after you leave here and you go back to your facilities or you go back to your customers and you have a list of tasks, which hopefully you have a framework to do now, you would say, all right, are these tasks that are common failures to us that we now want to avoid the failure, so we're gonna add them to our PM tasks? Y'all following that? So like you're saying, hey, we commonly are replacing fan belts and things are breaking, so we're gonna create condition-based maintenance tasks. All right. So this leads us to scheduling based on risk. So if you take one thing away from this, I want you to take away this action, which is to stop scheduling low-risk assets aggressively. So a lot of people, I see this especially in K through 12. K through 12 is notorious for this, where they spend very little time in the central utility plant and a ton of time on unit ventilators. And I understand it because, every classroom has a unit ventilator. They're those old like 1980s shakers that would be against the window and, they would just make that loud, annoying noise and drip water. So those things right there are something that a lot of people spend a lot of time on, and then they ignore the central utility plant, and then the chilled water goes down, and those things, right, or the hot water in more cases goes down, and those things have no way of actually producing heat. So make sure that when you're doing tasks, you're thinking through like, okay, this boiler feeds my entire building. And so if it fails, it doesn't matter if all this stuff works. I'm gonna be plugging in unit heaters or electric heaters or sending kids home. So I want to make sure that I'm going and prioritizing those tasks above other tasks. All right. So here's kind of the risk-based scheduling model. I try to keep things very simple. I try to keep them in threes. It tends the human mind, so if you're ever teaching anyone anything, teach it in threes because the human mind likes patterns. And so if you teach threes and you repeat the same thing, it tends to stick into the mind. So if you have to teach this to your people. So tier 1 is condition-based triggers. Tier 2 is hybrid time plus data. And tier 3 is extended intervals or elimination. So how do you do this, right? So condition-based maintenance, we've kind of already talked through that. So hybrid time plus data, what this looks like, runtime plus conditional data. So what that would look like is, hey, we've got runtime, but our fan speed's still fine. So even though we're past runtime, if our fan isn't like oscillating and now it's 75% speed instead of 20% speed, there's no reason to go change the belt necessarily. And then extended intervals or elimination. So that is where you can just go and say, hey, if these were things that we're just doing based on intervals, we may want to consider eliminating them and moving up. The goal is to move up the ladder. So in an ideal world, you'll get to tier 1. Did you have a question? Okay, cool. In an ideal world, you'll move to tier 1, which is purely data-based. But most people, they end up at tier 2, which is, if you do that, you're already going to be saving money. Does this make sense? Because this is a key concept. And if this doesn't make sense, I want to pause here and spend some time on it. Do you all understand what I mean by like moving up the tiers? Okay, cool. Awesome. All right, so let's write some executable tasks. This is something that I don't know if y'all's PMs look like this, but what we're gonna see is like writing, anyone heard SMART goals? My first attempt at writing SMART goals was, and probably still is, terrible, but writing SMART PM tasks is gonna be key. And it's really as simple as what to check, how to check it, and then a pass or fail criteria. So let's look at that. Inspect dampers. How many of y'all have seen this, like literally something like this on your PM? Like inspect dampers, look at filters, check valves, check actuators. Versus command damper to 100% open, verify position, make sure it gets the feedback if you've got a feedback sensor, and that whatever it's controlling reaches set point. So there's a lot in here, and I want to kind of unpack what this is actually doing. So 1, command damper to 100%. We're making sure that the damper, 1, is still going to 100%, making sure it didn't slip on the shaft or on the valve stem. We're making sure it's still calibrated, which who's familiar with floating actuators? Who's not familiar with floating actuators? Okay, so floating actuators, also known as incremental actuators, are a cheap way, and cheap doesn't mean bad, they're a cheap way of doing proportional control. So basically, you've got a motor, and you send it a clockwise or a counterclockwise signal, and so when you send it the clockwise signal, you'll have 2 BOs. You'll have a BO and a common, binary output and a common, and that'll drive it one way. And you'll have another, and it'll drive it another way. Then there's proportional actuators, which take a 0 to 10 volt DC signal or 4 to 20 milliamp signal, and they tell it to go to 0 to 100. The reason a lot of folks use incremental and floating actuators is because you don't have that conversion electronics that adds about $30 to the actuator cost. And so when you have 1,000 VAV boxes, you put an incremental actuator on there. It's good enough, and as long as it's calibrated, which it usually has an auto calibrate, it's good. But if you need a massive air handler or a chiller, you want that proportional actuator because you want that additional accuracy. Make sense? All right, so in this case, we're making sure, and this is a great one to do on terminal units, so we're making sure it still actually works, that the actuator is still properly calibrated and driving. Then we're verifying position. This is key point. It's one thing to command something to 100%, and then never go look at it and realize like literally it's off the damper shaft. It's just dangling there, and then someone took a 2x4. So I had this energy project where they put all new controls, and they couldn't figure out why it wasn't saving energy. And this like 70-year-old crusty mechanic guy forgot his password. No shit, like forgot his password, took all the controls off every unit ventilator in these 4 schools and was running them with like clamps. Like think about that for a second. Forgot his password and probably spent what, like 3 days taking these controls off the system because he forgot a password. So actually going and verifying the position is key. And then making sure it reaches set point, because let's say you drive a valve stem and you verified that it drove, but you're not verifying that it's cooling down the air. You're not verifying that cool water or hot water can still flow through that coil. Does this make sense? I know I spent a lot of time on this, but I see a lot of poorly written PM tasks, and then people wonder why they're yelling at their maintenance folks, and they're like, the PM didn't get done, and it's like, inspect device. And they're like, I did it. I looked at it. It's still there. So, please. Yeah. Not necessarily. So here's what I like to do. You can do a couple ways. One is you can videotape, if you get approval, the person doing that, have them say out loud what they're doing, take that transcript via like Otter AI, throw it into ChatGPT, and ask it to write a FM one sheet with like, hey, these are the tasks, these are the conditions, this is a failure condition, this is a pass condition. Have it do the work for you. So there's no problem with doing that. I would only do that initially for my tier 1 assets. But yeah, it's a good question. So the more detail you can give, the more predictable result you're gonna get. Have any of you all ever seen that peanut butter and jelly YouTube video where the dad is giving instructions to the kid to make peanut butter and jelly, and it's like they're putting the bread in the actual peanut butter jar? It's a funny video. Being very explicit, going back to the Ron Burgundy rule, they'll do whatever is on the paper. So, don't stick your hand in the 480 panel. It's usually a good idea. Good question. All right, so assign ownership and time. It's all well and good to have PM tasks, but if you don't actually assign anyone to the PM tasks, I have a high likelihood that they're not gonna get done. I mean, just gut feel there. So you wanna assign a role, define the time required, and define the expected outcome. This is key. Define the time required. You have no way to measure progress and proficiency if you're not giving a time. So, ask the folks like, hey, how long does it take for you to do this? Oh, it takes an hour? Okay, just believe them the first time. I mean, unless they give you something ridiculous, like, it takes me 10 days to change a filter. I mean, yeah, okay. But, within reason, define the time, and then measure the time. That's how you see if proficiency. And then you can actually, later down the road, you can train, you can measure proficiency increases. You can say, hey, if we have 1,000 VAV boxes and it takes 30 minutes to do XYZ task, and we reduce that by 50%, so now it's 15 minutes, that equals X amount of time. There's this cost per hour of my employees, so therefore I can spend this much on training them. So that's kind of how the mental model I work through when I'm deciding to make a training investment. Okay, step 7, review and adjust quarterly. So a PM program should be adjusted initially quarterly, in my opinion. And there you go, there's full slide. You wanna review, okay, what failed even though you had this PM program? Because, let's say you set up a PM program in August in Maine. Everything's great, the weather's beautiful, everything's amazing. And then, winter comes in October, pipes start freezing, boilers aren't kicking off, all sorts of stuff, and you're like, crap, I should have put in some boiler PMs. But if you do it a quarterly review, then you can come back and say, yeah, you know what? I should have done this, I'm gonna do this, and you add it. Okay, reduce the PM volume over time. So what you wanna do is try to review your PMs, do that quarterly review, This is why having like a CMMS solution is really nice, a centralized maintenance management software solution, some form of tracking of failures and logging stuff. I mean, even if it's an Excel spreadsheet or something, but having that so that you see, okay, I spent these times on these tasks, and these tasks had nothing to do with my tier 1 systems. They were like tier 3. Okay, well, I can take that and I can eliminate that and move it to my tier 1 or my tier 2. And that's how you reduce your OpEx, you reduce your cost, et cetera. All right, so let's build a plan. So if I had to start building a plan today, I would start with my top 10 assets. So that'll typically, in a modern facility, it'll look like your chiller, your boiler, your air handlers, and then usually, in my opinion, a lot of folks will debate between terminal units and exhaust. I tend to like, if there's an exhaust tied to building pressure, I tend to like to focus on that, because if you can't control building pressure and building envelope, which if we think about this room as a skin, right? If I'm not properly pressurizing this room, then all the bad stuff from outside the room is going to come in. So I want to push that away. So that's positively pressurized. And if I, for example, maybe there's like someone who's super toxic in here and they've got like COVID 2026 and they're going to kill us all and we got to be careful and we can't let it out of the room. Well, then we want to negatively pressurize it so it sucks it all back in, right? Well, so right there, that's why I like to look at like exhaust systems, because that goes and really helps you maintain energy efficiency and temperature control, in my opinion, more than like space. So I would do, chillers, I do boilers, I do main air handlers, and then I do exhaust, and then I would do like space control if I had to break things out. And that's for an office building. I mean, obviously your mileage will vary depending on your vertical. So you start with top 10, you do one failure mode each, and you have one BAS-driven PM task for each one. You do that, you'll be light years ahead of everyone else. Okay, so a 30-day plan. Take pictures of this. This is kind of a model for you all if you're gonna implement it. So within 30 days, an ideal goal would be to tier all your systems, clean your FM tasks from your PM tasks, and add BAS-driven triggers. So what this looks like, hey, these are my tier 1 systems, these are my tier 2, tier 3, and don't like spend more than 30 minutes on that. Just put them in there. It's good enough. If you can't decide between tier 2 and tier 1, it's good enough. Clean out your FM tasks from your PM. Like, what am I working on right now that's FM? Because that does not necessarily need to become a constant PM. And then add any BAS-driven triggers like runtime, pressure sensors, et cetera. Then from there, within 60 days, you want to validate that you put in the right triggers. You want to remove any low-value PMs, and then train your techs on the new tasks. This is where having those tasks be descriptive is going to be helpful, because then you can measure the success. And then finally, you want to go through and do your 90 days where you're going to review your failures, adjust your PM schedules, and lock in any standards. So there you go. And then what to stop doing immediately. So in my opinion, if I could do any one thing for you all, would be within reason, stop blindly following OEM PM intervals as long as it's not going to break your warranty. So there's certain things you have to do, otherwise they're going to come back and say, hey, we can't warranty this because you didn't do this task. So make sure you do those. But like other than that, like really consider where you put your time and effort. Because I mean, at the end of the day, they want to protect their equipment and they want to protect themselves from having to replace their equipment at their cost. So they're going to tell you everything that you possibly could do, and you may not have to do that. People aren't usually going to tell you that, but in my experience, that's the reality. Don't treat all assets equally, and don't measure your PM success by task count. This isn't a, I've got 5,000 PMs done, but they're all done on like, the toilet exhaust fans. So it's like, hey, the toilets smell great, but our building's burning down and have no chilled water and no hot water, but toilets are awesome. So yeah. What to start doing. So prioritize your tier 1 assets. Use your BAS data to trigger maintenance and review your PM effectiveness quarterly. If you do these 3 things, you'll find yourself in a really nice spot. So I told you at the beginning that we would come out of this with, a different way of looking at FM and PM. So if implemented correctly, this is what I see. Failures are going to decrease, reactive work is going to drop, PM workload is going to shrink, and your system reliability increases. So here's what I'd like you to do. I'd like you to spend some time. We have 20 minutes for question and answer, but also I'd like you to spend some time thinking, like, what is one tier 1 system I'm working with today? What's one failure mode? And what is one BAS-driven task? I want to spend some time kind of working through that, like question, answer, echo here. So I'll tell you all, this is very important. Pay attention to this next slide. Because one does not simply have 0 questions for the question and answer session. So this is our opportunity to work through things. You get 20 minutes of free consulting on your PM program. Floor is yours.
Test number 1. Test question number 1. When you guys walk up to your facility and you walk through the front door and you grab a hold of that door and you're like, oh, I gotta be Hulk Hogan to open this door. Why is that? Okay. And if the door about blows you over and knocks you over when you walk through the door, what's up with that? Yeah. How many of you pay attention to that when you walk into a building? Good handful of people. That's awesome. Do you pay attention to it in your own facilities? Good deal.
Do you try to help people not pay attention to it by leaving the doors open? Like, yes, we're Breezy Hospital. We're going to blow you away. What questions did I create? Do you all feel like I delivered on the initial objectives of this presentation?
Don't be shy. You won't hurt his ego.
This is my first time delivering this, so if this sucked, tell me. If it was great, if it sucked, it's his fault. If it was great, I'd take full credit.
So how would you go about diagnosing negative pressure in a building?
That's a great question.
Fans, shut off exhaust fans?
How would I go resolving it or diagnosing it?
Because our building was originally designed for smoking. I work at a casino.
Yeah.
We have bad negative pressure. It's like when you open them doors, they slam right behind you.
Yep.
And we're, obviously we're wearing out a lot of door closures.
Mm-hmm.
Yep.
Well, like I said, so negative or positive pressure is not necessarily a bad or a good thing depending on the scenario. So if you've got a hospital isolation room, right, and that's negatively pressurized to the outside corridor, that's not a bad thing. You don't want someone, who has freaking Ebola in a positively pressured room, right? So in that scenario, negative pressure in a casino that is mainly done for IAQ, you ask yourself, well, it's sucking air somewhere, right? So the question to me would be, not is it negative or positively pressured, but actually what are my air changes in the space, and do I have any form of IAQ monitoring, and am I hitting my PM quality for that actual space? So particulate matter quality. Am I hitting my VOC quality for that space? Because, if it's negatively pressured, like the casino floor, well, there's people smoking. So I would believe, and I'm not a casino expert, so definitely correct me where I'm wrong, but just making some assumptions here. The casino floor is negative. That means it's sucking air from other places. People are smoking. So yeah, it should be sucking it up. It's got to go somewhere, right? But if it's positive, then it's pushing into the restaurants and then, You know, I'm sitting there trying to eat my steak and I'm just smelling like Granny's cigar breath and I'm like, ugh. So, does that help? Yes, ma'am. Run, Scott, run.
You made a comment at the very top of the presentation saying that facility managers are doing more with less people, but with more data than ever. How can managers make these tiered systems with all this data that's available to them without it being so overwhelming to them, especially if they're more seasoned?
Yeah, that's a great question. So, you know, I see if you walk this floor, right? You walk the show floor and you talk to everyone. They're all like data, AI, you know, digital twin, all this stuff. And it's like, I just want schedules, set points that are easy to get to, and then I want to look at my alarms and trends. So what I tend to say is, if I walked into a facility, let's just say I walked into the worst facility ever. They had everything trended, everything alarmed, and it was just crazy. And you can't make any sense of that. No one could. So what I'd first do is I'd delete my trends, I'd delete my alarms, and then I'd sit there and I'd watch and I'd say, okay, well, I'm getting an issue with XYZ room. I'm gonna set up alarms there. And I'd start setting up alarms like, hey, this is my chiller. My chiller needs to be running, so I need to have a running. I need to have a status. I need to alarm that. I need to log my runtime. I need to log my condenser water and so the condenser side and the evaporator side. And that's how I would start. And I would do that because honestly, and that's scary to a lot of folks because folks are like, delete everything? That's nuts because I won't know what's going on. I would posit that you already don't know what's going on. I would posit that you're actually missing a ton of stuff that's going on. So that would be my approach, would be like, assuming you have the internal capability and time to delete that stuff and re-add it, because obviously if you don't know what you're doing and you don't have the time to re-add it, then yeah, don't. But if you do, that's how I would approach it. Does that make sense? Okay.
Also, you don't have to do the entire building.
But
Start with
fun.
one system at a time, right? Because how do you eat an elephant? This is always the saying. One bite at a time.
Live on the edge, Scott.
That's right.
Go and delete it all.
Yeah.
Just delete the programs while you're at it. Who needs graphics? What else? Yes, ma'am.
So talking about organizing your systems,
Yes.
This is a very theoretical question.
Sure.
What systems are over prioritized and what systems are often under prioritized?
In my experience,
Yes.
terminal units are very often over prioritized. I'll see zone temp alarms on everything. The really interesting ones are like zone temp alarms on storage rooms where there's no like hazardous storage. So I get it if there's like hazardous storage or if it's an electrical closet, like you don't want to heat stuff up, but it's literally nothing in there but some old books and they've got an alarm and you know the school shuts down or whatever and then now they're sending someone out because it's too hot, too cold. Building pressure is really under prioritized in my opinion. Plenum temperature is under prioritized, especially in the north. I see almost every year pipes popping and freezing because people, their space is conditioned, but their plenum is freezing because maybe we did this one district that literally, if you turned off the lights and looked up and you poked the ceiling tiles, there were literal holes in the ceiling because their roof had just worn out. So, and then they wonder like each year, why are we popping coils? Why are we popping pipes? So yeah.
Thank you.
Yep. What else? Yes, sir.
Okay, so for this method of putting together
Yes.
what size of facility will this work?
So typically, well, one, I would say, does the facility even have an FM team? Because none of this matters if you don't have anyone to execute it. Because there's 200,000 square foot commercial real estate spaces that are really, they're just passive income assets for an owner, and they don't care. Their lease is written in such a way that, like, if it doesn't work, that's the actual leasers or the rentalers issue. So that's the first thing I'd look at. Like, what is the asset type? Does it actually have FM capacity inside it? Usually anything above 100,000 square feet is going to have enough systems that's typically going to have some form of like air cooler, chiller, usually at that size. It's going to have a rooftop, typically some terminal units. So you want to have an actual distributed system. That's what I tend to look at. And then I look at, is there an actual FM team? So it makes no sense building FM tasks if no one's ever going to execute them. And let's be real, like some people, they just don't care. They just want to run it till it breaks. So, yeah. That was interesting. I didn't do it. They took my advice and deleted everything. So, what else? All right, so if there's no questions, I'll stand up here. If there's a question you didn't want to answer because whatever reason, you're more than welcome to come talk one-on-one. Yes, sir.
It's relevant, but your advice on taking over like a previous contract and you taking over, what would you do first? I mean, we have time to assess.
Yeah.
And do that, but what would you recommend?
So you're the contractor?
Yeah, the contract.
Okay, so are you familiar with like a conditions assessment?
There should have something, but it wasn't very good. Yeah.
So first thing I'm going to look at is, do I have mechanical drawings? Do I have a sequence of operations?
We're talking about ductless splits, a lot of them.
What's that?
Ductless split systems.
Okay.
1-to-1s, maybe.
What part of the United States?
Hawaii.
Hawaii?
Yeah.
Okay, so close to the ocean or far from the ocean?
It's hard to say. I would say central.
Okay. So you're not having to deal with like salt erosion, stuff like that?
Not really, no.
Okay.
But we do have an island, so, you know.
And I know Hawaii is really hard to get good skilled labor out there, and everything's more expensive. So first things first that I would look at for you is, what's the deferred maintenance? You can kind of tell that just looking. I would look at, what is the circa of the equipment? Are you taking over like full equipment coverage where you own the replacement, or just maintenance?
I would say just doing it raw and doing it all over and taking over. But I have some information and data, but it wasn't very accurate.
Yeah.
Yeah, I guess just starting over.
Because my big concern whenever I'm taking over like a ductless split system or something like that, that's very unforgiving if that equipment is end of lifed. It's not like, an air handler where it's, built up sheet metal and you could pull a fan out and put a new fan in. You can't just do that with a split system, especially dependent on, like, it may be a refrigerant that you can't even charge the lines with anymore. So I would get, like, what is the equipment? What's the refrigerant? What's the condition of the equipment? How's it been maintained? I mean, there's only so many things that can break with that kind of system. But that's what I would be worried about, is like, am I inheriting something that literally isn't made anymore, can't charge up anymore, and next thing I know, it's leaking and I'm doing a full system replacement? Yeah. Make sense?
Yeah, we do have that option of replacing too. So I understand the outdated Freons and, warranty life and stuff.
Yeah, so that's what I would look at. Yeah. I would do like essentially a risk profile of, and ASHRAE has a lot of data on equipment life cycles. So you can just do some swag numbers of like, hey, if this has been installed for 20 years, the likelihood of failure is X%. You can find that. I forget which ASHRAE standard it is, but I know there is one. Does that help?
Yeah, thank you.
All right, cool. Anything else, Bueller? No? All right. Well, you all are free to go get your drink gamble on, unless you want to come up and chat and I'll answer anything you got. Oh, there is, yes. One does
throw that
not
back up,
simply
Phil.
not scan the QR code. I have to go back.
Thank you all for coming.
Yes, thank you.
Appreciate you.
How was this? This is my first time delivering this. Was this helpful to you, or do you regret this life choice? No? It was good? I saw you at the one in Orlando, right? Yeah. We're getting there. We're getting there. I'm going. There it is.